Alright, fun with vectors. The sum of these three vectors is 0. There's the key. We add up three vectors and know that the sum is 0. We know that they start and end at the same place. Since we have just three vectors, we can work this with a triangle. If we had more, we could work it also with components. Okay, notice that we're given some information about C, so I'll write that over here. Probably a little easier to remember there. And we know the angle of each one of these vectors. B is horizontal, A is 15 off the negative y, and C's given us 15 off the y there, or 55 off the y. So let's draw it out. Remember, they have to start and end at the same place, and they have to be head to tail. So I'm going to draw out my A. And remember, that's 15. Going to draw fairly large. Okay. And then let's add B in there. It's horizontal. We don't know its magnitude. And C. So let's draw C coming back this way. Again, head to tail. Have to all add up. So C was 55. Get another color here. That angle right there is 55. Be careful with your angles. And its length is 15 meters. Okay? Be very careful with the angles and their references. So drawing it this way, I can see that this interior angle right here is 55 minus 15, or 40 degrees. Okay. I need a little more information. I know that this angle, opposite interior, is 15. So this whole angle right here is 90 plus 15, or 105. Okay, and that also tells me that I know that angle. Actually, you can get that a couple different ways. You know that this angle's 55. Is that right? Yeah, that's alternate interior with the 55. So this has to be 35. And as a double check, we can make sure they add up to 180. 105 plus 35 is 140, plus 40 is 180. So I know I have a triangle with all three angles known and one side. So it's completely defined. We want to find B. So B was our horizontal side. Alright. So law of sines is usually pretty easy. Easier than law of cosines if you can do it, which we can in this case. So I'll use law of sines. I'll say B over sine of the opposite angle. So opposite B is my 40-degree angle, is equal to C, the one I know, 15 meters, over sine of 105. Okay, so I can solve for B from that. I'm going to throw that in the calculator. 15 divided by sine 105, and then multiply by sine 40. 9.98. Okay, pretty close to 10. 9.98 units or meters. Alright, if I have time, I'm going to come back and work this with components, because that method always works. In this case, is probably don't have to mess as much with angles, but maybe a little harder, longer with components, but we'll see if that'll work if we have time.